In this video, we're going to run through a few questions involving complex numbers. In this question, we need to solve each of the following quadratic equations and then writing our answers in the form a plus or minus bi. Okay, so let's consider this first example. Okay, so the first thing we notice is that these quadratic equations are written with z's rather than x's, which means that we are interested in both complex roots and real roots. Now, to solve a quadratic equation, we still have to put it equal to 0. Okay, so if we've got 6z squared plus 1 equals to 2z squared, we are going to subtract the 2z from both sides to get 4z squared plus 1 equals 0. Now, as there's no middle term here, we can just move the 1 across and divide by the 4. So we're going to get that z squared is equal to negative 1/4. Okay, now usually we wouldn't be able to find the square root, but as now we're interested in complex solutions, we can square root both sides and get z is equal to plus or minus the square root of negative 1/4. Now remember that can be written as plus or minus the square root of 1/4 times by the square root of negative 1. So therefore, z is equal to plus or minus 1/2 I. Okay, so the answer to this is purely imaginary. We haven't got a real term, or if we were looking for it in this form, a would be 0. So that's perfectly acceptable to be our answer. Okay, so now looking at the second one. Okay, so this is a little bit more complicated to work out. So maybe I don't want to complete the square here. I might just rely on my quadratic formula. So if I look at my answers, so z12 is equal to minus b, so 3 plus or minus the square root of b squared, so that's 9 minus 4 times 7 times positive 3. Okay, so we can see that that square root sign is going to be negative, and that's going to be over 14. Okay, so 2 lots of a, which is 14. Okay, so that's just using the quadratic formula. So again, that tells me that z12 is equal to 3 plus or minus the square root. Now, what we need to work out is 4 times 7 times 3. So 4 times 7 times 3 is 84, and 9 minus 84 is negative 75. Okay, over 14. Okay, so we're nearly there, but we need to write this in the form a plus or minus bi. Okay, so if we continue, okay, so we get both of our answers are going to be equal to, well, 3 over 14 plus or minus, I'm going to split this up into root 25, root 3, and root minus 1, which I'm just going to write as I, all over 14. Okay, and then I can finally write my answers out. So z12, so there are two answers, are going to be equal to 3 over 14 is the real part, plus or minus, and if we simplify this down, it's going to be 5 root 3 over 14 I. Okay, so 5 root 3 over 14 I. Okay, so a little bit more complicated there. We had to work with our surds as well, and our fractions, as well as just thinking about the complex number. So a bit more involved, but we can see that we've still got a real part and an imaginary part to our answer. Okay, good. So let's look at this last one, so part C. And I will complete the square of this one because we haven't got a coefficient of z squared. Okay, so we start with z squared minus 8z plus 21 equals 0. And if we work through this, we're going to get z minus 4 squared. And if we expand that, we'll get z squared minus 8z. We'd also get a plus 16. Okay, so I'm going to minus that 16 and then add on the 21. Okay, so if I get now z minus 4 squared equals, so on this side I've got 5, so I'd move it onto the other side to get negative 5. Now I'm going to get z minus 4 by finding the square root of that side is equal to plus or minus the square root of negative 5. Okay, so that's going to be z is equal to 4 plus or minus the square root of 5, the square root of minus 1, or I. Okay, so 4 plus or minus root 5, I. Okay, so there's 3 examples of how to solve quadratic equations with complex solutions. Okay, so where there's no real roots, but there are complex solutions. And we've shown it in kind of 3 different ways. Okay, so the first one, if there wasn't a middle term, we can just work our way through it until we get the answer. The second one, I've used the quadratic equation and simplified down as far as possible. And in this third one, I've used completing the square to get to our complex solutions. Okay, so thank you for listening. In the next video, I'm going to go through a couple more questions on addition, subtraction, multiplication of complex numbers before we then move on. Okay, so thank you for listening. Goodbye.